Is this statement true? This statement I want to ask. So let's frame this as a question. Let's frame this as a question. So tell me, is this statement true? If a graph has exactly two vertices of odd degree, there are exactly two vertices of odd degree, then they are connected by a path. Then they are connected by a path. Why this statement is true? Before this statement, you tell me every component is a graph, right? Yes or no? Every component is also a graph. Every subgraph is also a graph. Correct? Every subgraph is also a graph. Every subgraph is also a graph. This you already know. Every component is also a graph. Correct or not? Every component is also a graph. Yes. So for example, if you take any graph G, okay, let's assume you take this graph G. Then you can notice this is also a graph, right? So you have a graph G, this is your graph. In this graph, you can notice this is also a graph. Correct or not? This is also a graph. And what about this? This is also a graph. This is also a graph. So every subgraph is also a graph. Every component is also a graph. Very simple thing. Now tell me, what do you think? If you have exactly two vertices, can they present in different components? Just tell me this point. If you have two odd degree vertices, let's assume you have exactly two, not more than one, not more than two, not less than two. Let's assume you have A comma B. Is it possible they are in different components? Is it possible that A comma B are in different component? Because there are exactly two vertices. Only these are the odd degree vertices. There is no other odd degree vertex. So is it possible that A comma B are in different component? The answer is very simple. The answer is very simple. That is no. Because if they are in the different component, like A is here and B is here, then what will be the problem? What will be the problem? Now this graph has odd number of odd degree vertices. Yes or no? Now this graph has odd number of odd degree vertex. Correct or not? Now this graph has odd number of odd degree vertices. Odd number of odd degree vertices. And how many odd degree vertices a graph should have? It is given that exactly two vertices are of odd degree. Let's assume these are two vertices of odd degree, A comma B. These are the two vertices of odd degree. Exactly two. Exactly two means no more than two, not less than two. You have exactly two vertices of odd degree. All other vertices have even degree. Only two vertices are odd degree. This is given to you in the question. If a graph has exactly two vertices of odd degree, so these two vertices are of odd degree, A comma B. Is it possible they can be in different components? Is it possible they can be in different components? Is it possible? If they are in the different components, think about it. If they are in the different components, then what will happen? Then this graph has odd number of odd degree vertices. Then this graph has odd number of odd degree vertices, and that cannot happen. We know that every graph has even number of odd degree vertices. But if in this graph now how many? In this graph now you have one odd degree vertex. One odd degree vertex you have. So odd number of odd degree vertices you have. So that is the contradiction. Basically, it is the contradiction. Yes, this is not possible. So they should be in the same component. So A comma B should belong to same component. And what this means? So they should belong to same component. And what this means? This means that there is a path between them. It means there is a path between them. Very simple. Okay, clear? But it does not mean they will be adjacent. Does it mean they will be adjacent? Does it mean they will be adjacent? No. They can be like this. You can notice, but they will be in the same, they will be in the same component. In this graph, you have exactly two vertices. You can notice in this graph, you have exactly two vertices of odd degree. In this graph, exactly two vertices of odd degree. This vertex, this vertex. So you have exactly two vertices of odd degree. They are in the same component, but they need not be adjacent. Is this clear? So this is the idea. If your graph has exactly two vertices of odd degree, then they will definitely be connected by a path. This same question people can ask you like this. Back to back, three questions have come in the GATE exam. All the three questions are on the same point, that in every graph, whatever graph you take, in every graph, we have even number of odd degree vertex. Remember, every component is also a graph. Every subgraph is also a graph. Every component is also a graph. So if you notice every component is a graph. Just notice every component. Every component is a graph. Okay, so in every component, what should happen? You should have even number of odd degree vertices. You cannot have odd number of odd degree vertices. The same question they can ask you like this. Show that in any simple graph, there is a path from any vertex of odd degree to some other vertex of odd degree. Basically, what this is saying, what this question is saying, this question is saying that whatever simple graph you take, then definitely there should be a path from a odd degree vertex to some other odd degree vertex. For example, it's like in any simple graph, if you are odd degree vertex, for example, if A is odd degree vertex, if you are odd degree vertex, then definitely you will have a path to some other odd degree vertex. Definitely you will have a path to some other odd degree vertex. This is what this question is saying. Is this clear? In any simple graph, if you are the odd degree vertex, then definitely you have path to some other odd degree vertex, because it is not possible that you are the only one. Yes or no? It is not possible that you are the only one, only odd degree vertex in a component. It is not possible. Agree? Correct? It is not possible that you are the only odd degree vertex in a component. So definitely you must have a path to some other odd degree vertex. Tell me, the same question they can ask you in two different ways. The same question. Now, this is your TIFR 2018 question. What will be the answer? TIFR 2018. In an undirected graph, you have an undirected graph G with n vertices. Vertex 1 has degree 1, vertex 2 has degree, each vertex 2 to n minus 1 has degree 10. Degree of vertex n is unknown. Total n vertices you have. Which of the following statement must be true? Which of the following statement must be true? So the question is saying that there are total n vertices. There are total n vertices. There are total n vertices. This vertex, this vertex, this vertex, this vertex, this vertex, and this vertex. This vertex has degree 1. So what is the degree? This vertex has degree 1. This has degree 10. This has degree 10. This has degree 10. This has degree 10. What should be the degree of this? Anyone want to tell me? Anyone want to tell me what should be the degree of this? Odd. It should be the degree odd. You must have degree odd. Okay, so the idea is very simple. See, all of them are even. All of them are even. And this is the odd degree vertex. So definitely from this vertex, definitely there must be a path. Definitely this n must be odd. First of all, definitely this n must be odd, and there must be a path. So this is odd. Definitely this should also be odd, and there should be a path. There should be a path. Can you notice? Very simple, right? If you notice, this same question they can ask you in three different ways. See, this same statement they are asking, they can ask like this, they can ask like this, or they can ask like this. And this is your TIFR 2018 question. So finally, you can notice that this is odd degree vertex, all other are even degree vertex. Remember, it cannot be even, because in a graph you should have even number of odd degree vertices. So this vertex n, this should have odd degree, this definitely should have odd degree. And I told you that if you are odd degree vertex, for any odd degree vertex, what we can say, if you are odd degree vertex, then there is a path from you to some other odd degree vertex, correct? So this is the idea. So finally I can say that there is a path from 1 to n. This option is correct. There is a path from 1 to n. Vertex n has degree 1. It is not mandatory. Vertex n has degree 1. This is not mandatory. But vertex n should have degree odd. N should have odd degree. Okay. So very simply, they can ask you this question in this, like this, they can ask. So remember this point always. Always understand a statement. By hearting will not help you. Let me tell you, for example, if you by heart this statement, then I can guarantee that you will not be able to solve this question. If you by heart this statement, if you just by heart, okay, like तुमने रट्टा मार लिया इस statement का, okay, you have by hearted this statement. Now I can guarantee that you will not be able to solve this question. Because why? Can anyone tell me why? Because you will not even feel this question. You will not even get the idea to apply this statement to this question. This idea you will not get if you don't understand this statement. What this statement is saying? This statement is saying that if you are odd degree vertex, then definitely you have path to some other odd degree vertex. Definitely this will happen. If you are odd degree vertex, then you have path to some other odd degree vertex. Or I can say, if there are two odd degree vertices, exactly two odd degree vertex you have, then they are in the same component. They must be in the same component. Okay. So this is the idea. Have you heard about this dialogue of Three Idiot? There is a dialogue in Three Idiot movie. There is a dialogue like this. कि हमने पढ़ा था, उसने अप्लाई किया. This dialogue is there. And this is actually very interesting dialogue. See, seriously, this is very interesting dialogue. This is very important dialogue for GATE exam also. Many people, they do this. Let me tell you. Okay, how many people do this? Let me tell you, almost 15, almost 10 to almost 10,000 people. Almost 10,000 people, they cover the syllabus. Almost there are 10,000 people, they cover the syllabus. They cover the syllabus. You remember? They cover the syllabus. See, these are the 10,000 people who cover syllabus. Who cover syllabus. And these are the people, and these are the almost 1,000 people. And these are almost 1,000 people who understand the syllabus. Who understand the concepts, I can say. They cover, these people cover the concepts, and these people understand the concepts. So this is the difference. This is the difference between toppers and all. Okay. So please be in this category. Whatever you study, you study by understanding. If you are study by understanding, then okay, basically this is very important. Whatever you study, like if I tell you some definition, if I tell you some idea, then you have to apply that to the question. Okay. So this is the idea.
Let's see this question. Quickly tell me the answer. In a graph, this is TIFR 2012 question. In a graph, the degree of a vertex is the number of edges incident on it. Okay. The degree is the number of edges incident on it. That is fine. Your usual definition, right? Yes or no? This is our usual definition. Standard definition. Correct? This is the standard definition of degree. Okay. Now, which of the following is true for every graph? Which of them is true for every graph? So the answer is, we already know the answer is, there are even number of odd degree vertices. There are even number of vertices of odd degree. So the option C will be correct. This we have already seen in the last session. We have already seen this. So the answer will be option C. But you tell me which of them is never true. Which of them is never true? See, answer will be option C. But you tell me which of them is never true. Never. Which of them is never true? So you can notice this is never true. There are odd number of odd degree vertices. This is never true. This is never true. Correct? All the vertices of even degree. All the vertices are of even degree. This may or may not be true. This may or may not be true, right? This may or may not be true. But remember, option D is never true. Okay. What about this? Even number of even degree vertices. Again, this is again may or may not. Again, this is may or may not. Again, this is may or may not. Okay. So the answer is very simple. The answer will be option C. Option C is always true. This is always true. Okay. Option D is never true. Option A, B, E, these are may or may not be true. Let's move on. Now I am asking this question. First of all, you tell me, is this true or false? Is this true or false? A simple question I am asking, is this statement, look at this statement, true or false? This statement on your screen, this is true or false? In any simple graph, there is a path from any vertex of odd degree to some other vertex of odd degree. Is this statement true or false? In any simple graph, whatever simple graph you take, there is a path from any vertex of odd degree to some other vertex of odd degree, Is this statement true or false? Why this statement is true? Yes, this statement is true, but why? This statement is true, but what is the proof? Like, why this statement is true? That if you have odd degree vertex, for example, if this is an odd degree vertex, then definitely there will be a path to some other odd degree vertex. This is A not equal to B, and this is odd degree vertex. There will definitely be a path. You can take any odd degree vertex. This can be any odd degree vertex. Okay, then to some other odd degree vertex, there will be a path. The statement is actually true. The reason is very simple. Because, tell me, simple question. If you take a component, okay, a simple question I am asking. Just take any component. Take a connected component. What will happen? Take a connected component. What will happen in this connected component? Tell me. Can I say this connected component is also a graph? Can I say that this connected component itself is a graph? Can I say this connected component itself is a graph? Itself is also a graph. Right? Correct? Like, if you have connected component in any graph, so you have a graph. Let's assume you have graph G. In this you have connected component C1. Okay, this is your connected component. This is your connected component C2. Okay, so this C1 means connected component. This is connected component. This is your C1, this is your C2, and so on. So can I say that this itself is a graph? Yes or no? This is also a graph. This is also a graph individually. This is also a graph. Individually a graph. Individually also a graph. Yes or no? This is a graph. So what should happen? So what should happen? If this connected component is also a graph, then what should happen? Then this would happen that in this connected component, number of odd degree vertices, how many should be there? Tell me. Then how many should be there? So in this connected component, this is your connected component. How many odd degree vertices must be there? Tell me. How many odd degree vertices must be there? So there should be number of odd degree vertices. How many? Number of odd degree vertices. That should be even. That should be even. Correct? Yes or no? Array, this is also a graph, right? Take any connected component. This component is also a graph. This is also a graph. This is a graph. This component itself is a graph. Correct? This component, this is a graph, right? Yes or no? Now you can notice that. Look at this component. For example, this component. This, look at individually. Look individually. This is a component. This is a graph. Individually, these are graph. Like I can say individually. Look individually. Individually, this is a graph. Individually, this is a graph. Now you can notice there should be even number of odd degree vertices. That's it. This is your proof. So now you tell me, array, if you have any odd degree vertex, if you take any odd degree vertex, then what will happen? If you have any odd degree vertex A, then what will happen? It will belong to some component. Do you agree? It will belong to some component. Yes or no? It belongs to some component. Definitely. It belongs to some component. Can I say it will belong to some component? Yes. So it will belong to some component. Then in this component, there will be another even number of odd degree vertices. Yes or no? So there will be another odd degree vertex. Definitely. So in this component, there will be another odd degree vertices. So in this component, there should be, there must be even number of odd degree vertices. Odd degree vertices. Okay, so there will be another odd degree vertices, definitely at least one. Yes or no? Correct? Array, this is already odd degree vertex. This is already odd degree vertex. There should be another, because there must be even number of odd degree vertices. This is one, so there should be at least one more. Maybe 3, maybe 5, maybe. Okay, so there can be number of odd degree vertices can be 2, 4, 6. Okay, so there should be another. There should be some odd degree. This should be, I can say this must be some odd degree vertex. This must be some odd degree vertex. And because they are in the same component, because this is a component, by the definition of component, what will happen? By the definition of component, what will happen? By the definition of component, they will have a path. Yes or no? By definition of component, they will have a path. By definition of component, yes or no? The component definition tells you that there is a path. Okay, because component is connected, right? Because component is connected. Okay, so that is the reason, by the definition of component, there is a path. So is this clear? Interesting, right? Yes or no? See, this same statement we are saying in another way. Did you notice this same statement? Look at this. Look at this option number C. This same statement we are saying in another way. Forget about remaining options. Look at option number C, and this option number C we can say in another way. Correct? Okay. This same statement we are saying, this same statement we can rephrase in many ways. Remember, we can rephrase this statement. Can rephrase in many ways. Okay, is this clear? Please tell me, did you understand? This same statement you can rephrase in many ways. This is one of those. Like I can say that in any simple graph, okay, in any simple graph, there is a path from any vertex of odd degree to some other odd degree vertex. So this statement is true, correct or not? Please tell me, did you get it? Like any odd degree vertex, there will be a path to another odd degree vertex, because in a component you must have even number of odd degree vertex. in any component you must have even number of odd degree vertex. So that is the reason I can say, by the definition of component, I can say that this must be true. This statement must be true. Correct or not? Okay, so this we have proven. What is another way to say this same statement? This same statement, this option number C, you can rephrase it in many ways. What is another way? What is another way? Let me give you another way. Let me give you another way. This is another way. Read this question. Is this true? Read this question. If a graph has exactly two vertices of odd degree, if a graph has exactly two vertices of odd degree, they must belong to same component. Is this correct? Is this true? If a graph has exactly two vertices of odd degree, graph has exactly two vertices of odd degree in your graph, in the entire graph, like let's assume this is your graph, this is your graph G. In this graph G, if you have two vertices of odd degree, exactly two vertices, let's assume like A comma B, these are the two odd degree vertices, then can I guarantee they must be in the same component? Can I guarantee? Can I guarantee they must be in the same component? Of course. Array, of course, it is not possible, right? Like A is here, B is here. This is not possible, correct? This is not possible because in this component you must have even number of odd degree vertex. Correct? Yes or no? In this component you must have even number of odd degree vertices. So this is definitely not possible. Okay, this thing is definitely not possible. So if this is not possible, then what we can say? We can say that they must be in the same component. If they are in the same component, then there will be a path. Then there will be a path. Okay, then there will be a path. Then there will be a path. That's it. Okay. So did you notice the same statement you can rephrase in many ways? In the GATE exam, this same statement they can ask you in many ways. This is the beauty of GATE exam, right? Yes or no? This same statement can come in many ways. Okay, remember this statement, this same statement can be asked in many ways, in several ways. So you tell me a simple thing, will you be able to solve in several ways? In several ways. Some of them I have already told you. Some of those I already told you. Is this statement true? Look at this statement. Is this statement true? They are connected by age. Is this statement true? They are connected by age. Is this statement true or false? They are connected by age. You have exactly two vertices of odd degree. They are connected. They must be connected by age. Is this statement true or false? Exactly two vertices of odd degree. They must be connected by age. Is this true or false? This statement is false. This is false. Very easy counter example you can give. Okay, very easy counter example you can give. Like here you can notice this is odd degree vertex, even degree, even degree, even degree, odd degree. So you can notice odd degree vertex, odd degree vertex. Okay, so this statement is definitely false. You can easily see this is the counter example. This is the counter example. Okay, so what I want to tell you, finally what I want to tell you, I want to tell you that these statements are true. Okay, then they belong to same component. This statement is correct, right? Yes or no? If you have only two vertices of odd degree, if you have exactly two vertices of odd degree, then they must belong to same component. Then they must be in same component. Then they must be in same connected component. This is true, right? Okay, so this is actually true. This statement we have already proven. Okay, if your graph, in this graph you have this is the graph. Okay, you have exactly two vertices of odd degree. So let's assume those vertices are A comma B, then definitely they can never be like this. This is never possible. Okay, this is never possible. This is never possible. The reason is very simple. The reason is very simple, because this is a graph. Array, look at this. This is a graph. Individually, look at this. This is a graph. This is a graph. This is a graph. So individually, these are graph. So individually, this must have even number of odd degree vertices. This must have even number of odd degree vertices. This must have even number of odd degree vertices. All of them must have even number of odd degree vertices. So if you have exactly two vertices, then they must be in the same component. Then they must be in the same component. So I can say they must be connected by path. So this statement is correct. So this is what I want to tell you. I want to tell you that this statement, in every graph, there are even number of odd degree vertices. Okay, this statement, the same statement you can write like this. This statement, all are same statements. Please tell me, understood? These three are same statement. So actually, let me tell you, do you agree with me? I am telling you one thing. Do you agree with me that in the GATE exam, if this statement comes, if the first statement comes, many students will solve it? Yes or no? This first statement, if this statement comes, then many students will be able to solve it, right? Do you agree? Because many students, they already know this statement. They are already familiar with this statement. But in the GATE exam, if this statement comes or this statement comes, then the probability will decrease. Yes or no? Like for example, maybe 99% students will solve this. Maybe 70% students will solve this, and maybe I can say maybe 50% students will solve this. So do you agree with me that the first statement, second statement, third statement, these are basically same. The same statement, the same theorem you are writing in three different ways. Yes or no? The same thing, the same statement you are writing in three different ways, but you can notice that if this statement comes in the GATE exam, many students will be able to solve, but these statements, some students will not be able to solve. Okay, so actually what happens here, this is the problem, that what we know we can't apply. Yes or no? So you must be Renzo. Okay, you must be in the Three Idiots, this Amir Khan. So you must be Renzo of Three Idiots. Okay, हमने पढ़ा था, उसने अप्लाई किया. You must be this. Okay, this must be you. What you study, you should apply. This is what I want. Okay. So what you study, you should apply. This should be you. Okay, anyway, so let's move on. Let's see this question. Tell me the answer. Quickly tell me the answer for this question. This is TIFR 2018 question. A very simple question. Tell me the answer. This is TIFR, Tata Institute of Fundamental Research. This is excellent institute. Okay, you should apply for this exam also. You should appear in TIFR exam also. This is brilliant institute. Okay, like Indian Institute of Science, IISc, CMI, ISI, TIFR. These are research institutes. Okay, these four institutes that I told you, these are research institutes. These are brilliant institutes. You should definitely attempt their exam. Okay, so let's see this question from TIFR. Tell me the answer. So the question is saying that there is undirected graph with n vertices. Vertex 1 has degree 1. These vertices have degree 10. Okay, and the degree of vertex n is unknown. Then first of all, can you tell me what will be degree of that vertex? Can you tell me? Can you tell me that there are n vertices? See, there is a graph, and the graph is undirected graph. There are n vertices. In this graph, there are n vertices. These n vertices are like this: 1, 2, 3, and so on. N minus 1, n. These are the vertices. These are your vertices. Now the question is saying that this has degree 1. Okay, so let's see. This has degree 1. This has degree 10. This has degree 10. All of them has degree 10, 10, 10, 10. This is unknown. Can you tell me what will be the degree of this n? Can you tell me what will be the degree of this n? Definitely odd, because number of odd degree vertices must be even, right? Definitely the degree will be odd. Okay, this degree must be odd. This degree must be odd. Now again you tell me, simple question I am asking. So can I say they must be in the same component? Can I say they must be in the same component? Like this vertex 1, is it possible? Is it possible that vertex 1 is here and vertex n is here? Is it possible? Like let's assume this is a connected component. This is your C1, this is your C2. Okay, this is a connected component. Okay, so this is a connected component. This is also connected component. So is this possible? Is this possible? The answer is this is never possible, right? Yes or no? Because this has odd degree, this has odd degree, no one else has odd degree, right? Yes or no? Correct? This has odd degree, this has odd degree, no one else has odd degree, no one else. So that is the reason this is never possible, because look individually, this is a graph. Here you must have even number of odd degree vertices. Here you must have even number of odd degree vertices. So remember, here you must have even number of odd degree vertices. Even number of odd degree vertices. You must have even number of odd degree vertices. Correct? Correct? Must have even number of odd degree vertices. So that is the reason this is never possible. Okay, this thing is never possible. That is the reason. Okay, so this I can say this is never possible, because no one else has odd degree. So this is never possible, because in this component you must have even number of odd degree vertices. So they must be in the same component. Finally I can say they must be in the same component. So you can notice this is the component. This v1 and vn must be in the same component. If they are in the same component, then by the definition of component, what will happen? By the definition of component, what will happen? If they are in the same component, then by the definition of component, there is a path. By the definition of component, okay, there is a path. So there will be path between them, you can say. So finally your answer will be that there is a path between these. So that is correct. This statement is correct. There is a path. This is correct. Okay, the remaining are actually wrong. The remaining options are wrong. You can create counter example for the remaining options very easily. Okay, let's see this. Option B. Option B is saying, what this option B is saying? This is saying that there is a path from vertex 1 to each vertex. This is not necessary. For example, option B, counter example for option B. Let me take, okay, let's take counter example for option B. Counter example for option B. So what is the counter example for option B? Option B is saying that, what option B is saying? This is saying that there is a path from vertex 1 to each of these vertices. To each of these vertices. So that is definitely wrong. Okay, what you can do, you can easily create a counter example like this. What you can do, just create like this. This V1 and Vn you connect. Okay, now this is degree 1, this is degree 1. And the remaining vertices like V2, V3 and so on, Vn minus 1. The remaining vertices. Okay, let's assume that the total you have, let's assume here you have, what you can do, if you have 11 vertices here, so like V12. So what you can do, you can take n equal to 13. Okay, take n equal to 13. You can take n equal to 13. Okay, so you can take n equal to 13. Then you can notice that now you can make a connected graph here. You can make a complete graph here. You can make a complete graph here. So all the conditions are satisfied, right? Yes or no? Correct? Yes or no? All the conditions are satisfied. Do you agree? All the conditions are satisfied because you have a complete graph. So this at degree 10. So you can notice this at degree 10, this at degree 10. Everything has degree 10, 10, 10, 10, 10, 10. So all the conditions are satisfied. Do you agree or not? All the conditions are satisfied, but there is no path between these vertices. There is no path between V1 and all these. So this is the counterexample for option B. Did you understand the counterexample for option B? So option B is wrong. Option C is also wrong. Option C, that is also wrong. What you can do? You can connect counterexample like this. Option C is also wrong. What you do? You take n equal to 12. Okay, and you make a complete graph of V2 to V12. You make a complete graph of V2 to V12. V2 to V12. You make a complete graph. So at this point of time, tell me what is the degree? At this point of time, what is the degree? What is the degree of this vertex? This vertex has degree 10. This vertex has degree 10. So every vertex has degree 10 at this point of time. So there is a problem here. So what you can do? But where is V1? So what you can do? You can put V1 here. Now you can notice. This will be degree 11 and this will be degree 1. Did you notice? This is the counterexample for option C. For option C, this is the counterexample. Is this clear? Let me know. Tell me, is this clear to everyone? So everyone has degree 10, 10, 10, 10. Everyone else has degree 10, 10, 10, 10. You can take n equal to 12. And you can see all the conditions are satisfied. This is odd degree. This is odd degree. Odd degree, odd degree. Okay, both has odd degree. So you can notice all the conditions are satisfied. But this is the counterexample for option C. So option C is not correct. What about option D? The diameter of graph is at most n by 10. The diameter is at most n by 10. This same counterexample will work. This same counterexample will work. This is the counterexample will work. Tell me for this graph, what is the diameter? Tell me what is the diameter for this graph? What is the diameter for this graph? Tell me. On your screen, this graph is there. What is the diameter for this graph? Let me know. This graph, this is complete graph. So the diameter of this graph will be what? That will be 2 from V1 to V2, from V1 to V3. That will be 2. So the diameter will be 2. But the option D is saying at most. Option D is saying at most n by 10. Option D is saying at most n by 10. But you can notice 2 is not less than this. 2 is not less than equal to this. Yes or no? Is this clear? So 2 is not less than equal to this. 2 is not less than equal to this. Is this clear to everyone? Because remember, because this option is saying at most n by 10. At most n by 10. At most n by 10. But you can notice 2 is not less than, so this is, you can see that. So definitely this is false. This statement is false. Automatically this statement is false. So the answer will be what? Answer will be only option A. So this option A is correct. This is the complete analysis of each option. I have given you complete analysis of each of option, like option B, option C, option D, each option complete analysis we have seen. Please tell me, is this question clear to you? Very beautiful question, right? Yes or no? In the TIFR exam. A simple question, a very nice, simple question.